Good evening. Today we are going to complete what we started last Wednesday. We looked at prompt chains and we looked at how we could do prompt chains by manually building it, writing a lot of stuff from scratch. We wrote the prompts and then we used some basic, um, Python F strings to replace the content. And then we did use an SDK basically. And of course, we chained everything. So if you look at the code that we did then, at least the the Python version of it, of course, it did what it did. But what if you had to deal with more complex things, more complex chains? So it's a bit challenging, right? To even understand what is going on. So we also started a little bit with the LCell, the long chain expression language, which is used for not just chaining prompts, but chaining everything. And really, that's why long chain is called long chain, starting from the LLM itself to the prompts to other um, tools and um, functions, utilities. They call them all runnables that can do all kinds of things. So we saw how, for example, a string output parser allows you to extract just the content from the response that you get from an LLM. So we did a little bit, right? It was kind of quick, just to demonstrate how it works. Today, I'm going to delve a little bit more in depth to explain how all of this works. And we're really going to start by looking at prompt templates and how we handle them in LangChain. And then after that, we'll come back to talk about um, generally how we put all of those things together, right? So what we call a prompt template, right? In in LangChain is basically just a set of utility classes that allows you to deal with prompts. Um, Now, first of all, you have to understand that a prompt in LangChain has more functionality. A prompt, just like every other thing, is a runnable. Runnable means it can run and they can interact with each other. They can take an input, a runnable can take an input from the output of another runnable, and then it will send an output, which another runnable downstream of it can take as an input. And that's the principle around which LangChain is built, which allows you to chain stuff. So um, now in the middle of all of this, everything comes down to, everything starts with a prompt. So um, you have the basic prompt template. You have a prompt, then you have a prompt template. So a prompt template class allows you to create prompts, prompt objects from a template. And in this case, a template is just a string that contains um, a prompt, but in addition to the prompt, it contains placeholders, which you would then replace dynamically at the point of invocation with real values. So if you look at what we have here now, you see that we have this prompt. It is a string. And then you have a placeholder here. You have another placeholder here. So placeholders are normally represented or identified with these braces. There are two ways that you can identify placeholders in LangChain prompts. The first one is this single brace, which we typically call that an F string type of placeholder because it actually originates from the Python F string. In fact, if you look at this, this is how you would normally write it in Python. Python, you put an F. F in this case means format. So it's going to format the string. And anything that is in braces, single braces like this, it will find a variable that has its name, topic, and then it will replace it with the content of that variable. So for example, if topic had prompt template inside it, then explain topic would be explain prompt template. That's how an F string works in Python. And generally, that is the same principle. In fact, that behind the scenes, that's the same mechanism that LangChain is then using for a prompt like this to replace the um, dynamic components. But the difference there is, of course, if I did an F string, I would have to pass, maybe if I am printing it, for example, this topic has to exist as a variable. Otherwise, you will have an error that says you're trying to print a variable that doesn't exist. So, in the same way, if you are using it in LangChain, you create a prompt. When you create a prompt, you invoke that prompt. So a runnable is invoked. So you see all of the LangChain components that are runnables, you call them using the same method signature invoke. Then when you specify invoke, you will specify a dictionary that contains whatever replacement values you want to use. So in this case, for example, we'll call prompt.invoke, and this system type, we specify what we want to replace it with, the actual value of system type, in this case, e-commerce. And then the requirements too, we also replace it. So that's the um, whole kind of simple overview of how prompt templates work. And the benefits of this is reusability because it's easy for you to reuse the same prompt in multiple places just by being able to replace the dynamic parts. Maintainability, you have your prompt in one place. It's easy for you to improve it, make changes, and so on. And if you're using the same prompt in multiple places in your code, you don't have to go look for all of them and be changing things up and down. The parameterization is what I just said, where you can include dynamic aspects of it. And then you have a centralized prompt management. So we'll look at that. Now, there is a second type of second format, right, that you can use. If you go to LangChain documentation, you will see they have what we call a mustache format. The mustache format allows you to be more expressive. So, for example, if you are putting in placeholders that are a bit more um, difficult or a bit more elaborate, right? It is really going to be difficult for you to use a simple F string, right? Because if you're using a simple F string, there may be clashes. So typically what you would do is to use a mustache format. I'm going to show you the documentation for that. So if you check prompt template format here, so you see the format, you have the F string format, like I said, and then you have a mustache. The mustache format has a double braces. And what the mustache format does is it actually uses the mustache markup system. Mustache is a well-known markup system that you can use is used even with HTML and so on if you want to inject dynamic values or variables. So Mustache is very useful generally. So they have adopted this Mustache format and it allows you to handle really complex data structures. In the normal F string, you cannot just you can't put like a JSON encoded string inside an F string. It will cause an error. But if you wanted to put in a JSON encoded, you can use a mustache. So the mustache allows you to do more elaborate stuff to embed more complex, things into your prompt. So what this does is that it actually allows you to be more expressive, to have more flexibility when you are managing prompts. And it is very, very important. So as you can see here, some of the limitations with string is you can't do dot notation, for example, right? And format specifiers and all of those really interesting stuff. But with the mustache, you can do all of that and a lot more. So this is something I would encourage us to take some time, go to the documentation, go to um, docs.langchain.com, go to Langsmith, and go to prompt template format. Of course, the reason why they put it under the Langsmith, you know, area is because the prompts in LangChain have been moved into Langsmith. Basically, this is to allow you to have what we call a prompt registry where all of your prompt can be stored on Langsmith for, later use. So you don't have to keep rewriting prompts. So that's kind of the background behind it. Now we are going to look at a few examples of what you can do with you know, a simple prompt template. So there are two versions. Let me just, yeah, we can start with this. So there are two versions that LangChain provides. The first version is called, it's basically a prompt template, right? So let's start with that one. The prompt template allows you to um, load, it's more expressive, right? And is used primarily for standard single input string prompts, right? Um, and it uses the F string, like we just talked about. It uses mustache, and there's also another format which we call Ginger 2, which again, um, that one is also available because the LangChain supports Ginger as well. So if you are already familiar with Ginger 2 or Ginger template, you can use that. So that's the first one, right? Used primarily for standard, single input string prompts. It supports F string, mustache, and ginger, right? So that's. So how do you do this? So the first thing is you will we can import the class, and I'm also going to do this with JavaScript as well, so that we can see how it works. So prompt template is now under LangChain core, right? Um, I think if you try from LangChain, it might not work. Um, it might not work from LangChain. So it has been moved to LangChain core. It's in LangChain core, LangChain underscore core. So that's a LangChain core module. So this is standard prompt template. Okay. So with standard prompt templates, the way you just do it is um let me do this on a new block. You create a new prompt. So remember, prompt is a runnable. So you create a new prompt and you initialize that prompt from a prompt template. Prompt template has multiple functions or multiple ways you can create a prompt. You have the first from. In fact, typically when you do from this or from that, right, you can get different ones. So you can already see that this already shows you the different ways or approaches you can create prompt templates. There's a from examples, okay? Then there is a from template. So the from template, which is what we'll start with, is a string template. So of course, the template has to be a string that already is um, um, so this is like tell me a joke about something, right? So already I have introduced this as a placeholder. Okay. So with this, I've created it. I've created the prompt. Then the next thing is to fill in this placeholder, you would use, it is at the point of running the prompt. So prompt.invoke. Then you pass in the variables. If you don't pass in, let's see what happens if you don't pass in the variables. Um, of course, it will not let you because you have to pass in the variables. So here I just tried to invoke without passing in anything. And it already tells you missing one require positional um, um, argument, which should be the thing that contains, you know, the variables. But now the variables are empty. Okay. Of course, I've passed in the positional argument. It's just an empty dictionary. And it's now telling me that the variable something is missing. So the prompt template is actually able to go through the entire prompt and extract out all of the placeholders. And it will expect you to fill in all of the placeholders. If you miss any of them, then it will not run. So here we can now um, pass in some values. So you always pass in a dictionary where the key is the same name as the variable, the placeholder, and then the value is the actual value you want to pass in. So when you do this, it will now be happy and it gives you that. So you can see you now have a string prompt value. That is, you now have a prompt and with the actual value replaced. And that's it, right? There are other ways you can, but this is like the simple, straightforward, modern way of handling it. Now, you could also have a file. So let's assume I have a file. Um, so I can create a new file here and I can put a prompt here, system.prompt.md. So I have a markdown file. So I'm going to go look for the example we did before. And from that example, I'm going to move because, remember we just did an example sometime last couple of days ago where we did prompt chaining and um, let me see if I can get that. And I want to copy out the variables. So I want to copy out the variables so that we can gradually build up um, we'll do the same thing, right? We'll do the same task, but this time around we're going to use LangChain. So a couple of so while I'm moving that anyway, I'm going to continue with how you would load it. So this is loading from a template, which is a string. So the second way you can load from a file is let's just call this one prompt from file, but it's still the same thing, right? This time around, you use prompt template dot from. So you have from file here, okay? So in this case, you are going to specify the file name of the file. And right now, let me just call it system.prompt. dot md. So that's the one I just created. So effectively, it's going to read that. And I can also do prompt from file dot invoke. So let's see what happens with this. So the same way I need to pass in the input, which is the dictionary. I pass in an empty dictionary. Of course, it's going to give me an empty text because there's nothing in that file yet. So I'm going to bring the file in and open it so that we can copy the original system. Um, let's see, I think it's here. Yeah, so we did prompt chaining with SDK. So if you look at this, you will see. So I'm just going to take each of the 5 prompts that we did. We'll put it in files. So let's start with the first one. And that's where LangChain now becomes very useful. Here we add this large amount of text, large prompts, and sometimes you can get lost in it. But with a a prompt template, you could just add it here, and then you can manipulate that. I think it's not allowing me to modify this because I named it .md. So I'm going to rename it to just .txt. Um, as a .txt to allow me to modify it. So that's the interesting thing. Okay, so I have a system prompt. Now of course I'm going to change this to system prompt.txt. Okay. And if I run this now and run, so you can see the entire prompt is here as well. So I have a prompt. In the same way, I could actually do all of the prompts. So sometimes you want to organize things very well. So let me create a new folder here, and then I'll add prompts there. So I have prompts in this folder, and then I'll move all the prompts in there. So um, I'm going to create a number of additional files that I want. Um, so we could just call them prompt one. I think we had 4 prompts also that we were working with. So you have prompt one, um, we have prompt two, prompt three, prompt four, prompt five. So the prompt one is the identify intent. So note that when I'm copying this, I don't copy the quotations. Quotations are only needed for string. I don't need the quotations when I am having a file. So prompt four. So we can open prompt one, and I have that here. We can open prompt two. Prompt two is this one. Again, I'm not copying the quotation marks. And then prompt three. then prompt 4. So the product inquiry prompt, then prompt 5 is prompt 4. And I'll create a prompt 5. Prompt 5 is the complaint collection. So the beauty of this approach is that you are actually keeping these prompts permanently. Of course, all of this will disappear once this thing is done. But in real life, in a real thing, um, you would have this. You could even have these prompts in your um, working directory, right? You have it under version control. And this is one of the things I was saying last time, that when it comes to prompts are a key asset, just like your code. Prompt is essentially your code. The only thing is that the code, it is written in natural language. So a prompt is a specification document. It holds the things that guide your AI. So the prompt is the driver behind AI. Okay, so if we invoke this now, we don't need to so let's do this. Okay, so we'll have system prompt. I'm going to call this system prompt. Then the system prompt, right? I had moved this file into the prompts folder. So prompts slash system prompt. And this is okay. So we now have prompt 1. Prompt 1, right? The interesting thing is that if you invoke prompt 1 now, if you invoke prompt 1 now, it will fail if you don't pass in the, the placeholder values. If you don't pass in, because prompt 1 now has additional parameters. So it has LangChain has detected that you have this customer message. So you are supposed to pass it in. Okay. Right. So that is one way using the prompt template class. Okay. The prompt template class allows you to just call from template or to call from file. From file means you can load it directly from the file without having to think about, let me load the file by myself and all of that. Okay. Now, there is a second um, type of prompt template that is called a chat prompt template. So a regular prompt template, you just put in a prompt. If it is from template, you put in a prompt. Okay. And you could also specify the template format. As you can see here, the default template format is F string. But if you have a different template format, you specify it. Same thing with from file, you also can specify the template format as well. Now, the second way that you can load a prompt is using the chat prompt template class. So what's so special about the chat prompt template? The interesting thing is that the chat prompt template is a subclass of the prompt template. So it has everything that the prompt template has, but it has additional stuff. So the additional stuff that it has is that it is structured to work with LLMs, chat models, especially chat models that require structured messages. Okay. So this is specifically designed for chat models. And these chat models, of course, LangChain has a format. Um, like I said, OpenAI also has a format, right? And I think a lot of people, a lot of vendors are going with the OpenAI format. Gemini has its own, or Google has their own separate format, right? So I think there are like three, four, or five. I think there are either three or four clear formats, right? That have kind of taken um, are leading in terms of the format for the structure of data that you send to LLMs. Okay. Um, if you go back to look at the API endpoints, like we talked about, you see there are different ones, but all of them are kind of revolving around the OpenAI format, the Google Gen AI format, the Anthropic format, and then LangChain has its own format. And LangChain kind of tries to unify all the other formats so that you use a single format. So now the main thing with this is that when you are passing um, the messages, you don't just pass a string, right? You pass the role of the message. And there are three broad, well, there are three, but there are up to five right now, broad rules, right, of message that you can specify. And what I mean by rules are designations of what that message or who made that chat or that message. We have three right now. We have a system message, which we've already talked about, or system prompt or system message. System prompt is the prompt that kind of always is there, and the LLM will always take that as a contextual general instruction to follow. That's system prompt. Then the user prompt, which will have a role of user, is going to be the one that the user types in into your app. And that is the one that's always dynamic. That's the one that is the basis of the conversation you're having with the user, or the user is having with the LLM. Then you have the assistant role, the assistant prompt. This is typically used to designate the response from the AI. So sometimes it is called the assistant, sometimes it's called the AI assistant. Um, so those are the three roles. But now with agents, we also have a fourth role, which is for tool calls. So there's a tool call. If the assistant wants a tool call, and then there's a tool call response or a tool call result. So those two and a bunch of others. Over time, these things are essentially evolving. So these are the three roles that we can start with. With chat prompt template, you can then specify a structured message or a structured chat. So the chat prompt template, again, is from LangChain Core. So you still get from LangChain Core prompts. You import the chat prompt template. Okay. Then you can now create a prompt. An instance of the prompt is chat prompt template from messages. So remember, the chat prompt template is actually a subclass of prompt template. So you can still do chat prompt template from file or chat prompt template from template. You can still do that, it will work. But the prompt template doesn't have this one from messages. So the from messages allows you to stack a number of messages that you send. Okay. And when you're stacking those messages, you can then specify the types of message. So there are two ways you do this, and I'm just showing the two ways in Python, but there are actually three ways. The first way is just the message. This is just a plain message string. So when you specify a plain message string like this, it's going to default to the role of user. because in this string, you did not specify what the role of this prompt is. Because the chat prompt template allows you to stack multiple prompt messages as in a list, which is what's happening here. And that's how you can stack the conversational history. That's also how you can stack system messages along with user messages. So if you're using a OpenAI, by the way, the OpenAI, first of all, if you're using, you can use a flat string. If you use a flat string, there's not a structure. It just takes the string as the content, and then it assumes that the role is um, the user, okay? User role. Then the second approach is use a tuple, which is just think of it as a list. In JavaScript, this is done with a list, a simple JavaScript list, where the first element refers to the role, in this case, the system role, and the second element is the actual message itself. And then you have a third way of doing the same thing. In this case, you have a full dictionary, um, and in JavaScript, will be an object where this is you are specifying role is user and content is this, right? So you can choose to use any of these. Um, by the way, these are for your information. When you are using LangChain, you can see LangChain allows human and AI. So there is no if you want to, let's try this. You could also just do the rule is AI, right? For LangChain, they use AI. This is the response from the AI, right? Even though the rule is assistant, but LangChain uses AI to represent it. However, um, if you were to use OpenAI standard, OpenAI actually uses the rule name for OpenAI is assistant. So you need to be careful of some of these things, but they still map to the same thing, right? What we call assistant in the OpenAI standard is what we call AI. That's the role AI in the LangChain standard. In fact, what I want to try now, right here, is whether LangChain can understand the OpenAI standard. If it doesn't, then we'll also know, get an error message, and that will be an opportunity for me to test it out. Okay, right. I could just run this, and it did work. So now that we have this, let's see how, and this is how LangChain is able to achieve the compatibility because it can understand each of those standards. I can now run a prompt.invoke, and there are no placeholders, right? So, but I could still put this in, and then let's see what we get. So you can see it has translated all of this. The first one, this is just a plain message string. It has translated it into a human message, right? The second one, we specified as a system message. It has translated into a system message. And then the third one, which we called role user, it has also translated into a human message. What's the meaning of life? Then this one that we used AI, it has translated into an AI message. Oh, that's not that one. That's this one here. So it has translated this into AI message. This is the response from the AI. And then the one I said role assistant, it has also translated into AI message. So it kind of understands that. Let's try, you could also try user, um, another meaning of life. And then let's try one, this time around, we use a tuple, we use assistant, right? Um, then let's try something that is totally unknown. Maybe we just call it a random rule. So just to show you, because you may begin to think, oh, I can put anything I like, right? but you really can't put anything that you like. If we run this now, I expect to get an error that it does not recognize this one. Okay. So unexpected message type, a random role. Use either human, user, AI assistant, or system. So it gives these options. So you cannot just put any role you like. You have to follow the conventions. All right. Um, Now the interesting thing is that with LangChain chat templates, you can also still um you don't need to go through all of this. LangChain also provides additional classes, helper classes that will help you. So from um the human message um and all of that, you can, directly call them and use those classes, right? So those classes are in LangChain called of messages, basically types of messages. And LangChain has three types of messages. So if I am using those three, the human message, like I say, is mapped to the one that is AI or that is user, row user, or the one that you don't specify a row, like a plain string. The AI message is mapped to the one that you mark as AI or assistant, while the system message is mapped to system. So you will see that at the end of the day, when the chat prompt template normalizes whatever you type in here, you're always going to have these classes. So you can just straight up decide to do that. And, you could say prompt equals chat prompt template from messages. And you have a list of the messages. So you could now say human message. Okay, let's start with the system message, right? Okay, chat prompt template. So you just this makes it easy for you to enforce a type without having to do too much typing. So you can be assured that this is a system message, this is a human message, this AI message. This is basically the same thing as if you had written it using this other kind of structured format. So LangChain gives you the flexibility to use this really flexible format so that it can still be compatible with existing systems that were using this kind of approach. Or you can use this structured data format using the classes that have been provided here. So when you do this, you are essentially making up prompts that then um, have history. That's the beauty of a chat prompt template. Okay, so that's really about all the things you can do with prompt templates. Now, of course, the next thing is, like I said, when you invoke the prompt template, you have to remember to pass in all the variables. If you have a prompt template that doesn't have all the variables, for example, let's see the one that has two variables. This one here has one. So prompt four, I think prompt four has customer message and product info. So if I want to do prompt four, I would do something like this. I can still use a chat prompt template, by the way. Prompt four equals chat prompt template. Now here we can use from messages, right? The reason why we can do this is because then we can use the system message, the system prompt, and we can just put the system prompt directly in here. And then we can then create a new prompt. We either put in the text directly or we create a new prompt um, from the we can just create a new prompt. Well, let's do it without the system prompt first, just to yeah. From file, let's do the from file first. So from file, we'll get prompt for. I wanted to test something. So let's okay, It looks like the chat prompt template, you can't get it from a file, so you have to use the regular prompt template. You can get it from a template, but you can't get it from a file. So let's use a prompt template from file. So we load that file and invoke it. If I invoke it with, so again, it's telling me I have missing variables and it's telling me there are two. It mentions it too, the product info and the customer message. Now, if I supply only one, it still will not accept it. So for example, customer message, I am having an issue. If you run this, it still is going to fail. It's now only mentioning the one that you did not supply. So you have to supply all of them. You have to supply all of the variables. Okay. So you have your prompt template. So basically, this is how you manage prompt templates. Now, there's something I have not really tried before with chat prompt template, which is composing chat prompt templates from other templates. So I'm going to try that now. So I could make a new prompt template like compose from, sorry, a new prompt. So remember, from messages can take a regular, but let's see if I can just pass in a system prompt here. If you do this, yeah, you cannot, you would actually have to extract the message out from the system prompt. So you cannot just compose it that way. But if you invoke this, of course, when you invoke the system prompt, you are going to get the actual original system message. So that would also work. Yeah, well, I'm trying to do undocumented stuff here. Okay, so this is this is how you handle prompt templates. Now, composing the prompts, we'll look at that later on. So now we have handled the prompt templates. Okay. The next thing is we are going to look at how we will pull everything together. We had already somewhat done this. Okay. But I'm going to explain it again. So remember, the first step is that you are going to build a chain, and the chain um, is made up of runnables. Everything is a runnable. The prompt that we just created using a chat prompt template and so on is a runnable. The LLM that you create from Chat Google Generative AI or Chat OpenAI or Chat Anthropic or Chat Grok or any of them is also a runnable. You can then chain them, and runnables, you combine them using the LCL operator in Python, which is the pipe symbol. In JavaScript, there is a function that you will call and you pass it in. So it's still the same kind of thing. You are still chaining it. It's just that the pipe operator is not available. So you can then create a prompt from a prompt template, and then the prompt becomes the first in the chain. You pipe it into the model, right? And we did that yesterday. So rather on Wednesday. I'm going to show you again. To do this, it's let's do prompt chaining with Well, we have to continue with this because I have this whole bunch of prompts. Okay, so now um I want to chain it. So I have to first of all make an LLM. So I'm just going to make an LLM from um chat. Um, let's use chat Google generative AI. And then you will specify an API key, or you just have the API key um as an environment variable. Then we specify the model. And in this case, I want to use Gemini 2.5 Flash or Flash Pro or Flash Lite. Of course, I have to first of all import this um, from LangChain Google Generative AI or Google Gen AI. In this case, it's Google Gen AI. Import this. This will not work because I haven't installed it. So I have to install it first with a pip install. LangChain Google Gen AI. So that will install here. And then um okay, it's done installing. Now you can import it. And when we import, we have it. Okay, yes. Um oh yeah, the typo here is this should be uppercase I. So the uppercase I works. Now I have to create the API key. So I create an environment variable. Of course, I have to also import .env from .env, import load.env, and then run load.env. But before I run load.env, I have to bring in my API keys. So we'll just go with Gemini API key, and need to go bring that up from where I have the Gemini API key. I'll put that in there. So okay, so yeah, so we have that. Okay, so with this, I yeah, so run the .env. True tells me it has loaded it. I run the LLM. So I now have an LLM. So I have two components. I have now prompts. I have all of these prompts that I have created already. And then I now have an LLM. That forms a basic chain already. You could easily now chain these two. So let's start with a simple example. I could say prompt is prompt prompt template dot from template. Okay. Um yeah, tell me a joke about something. So I think we did that already. So that gives me that. Then I can now create a chain. Of course, the prompt itself you can invoke, right? Like I say, you pass in the something. So this works normally. then you can also invoke the LLM because the LLM is also a runnable, right? Um, invoke always uses the same standard. You have to pass in this. Now, this has failed because you did not pass in a prompt. If you really want this to work, directly invoking, we'll have to pass a list of base messages. And a base message is essentially this. So you would have to pass in something like this messages, right? Is you can actually pass the message. Who are you? And this works. This is the format of the input that you pass into um okay. Um right. I think I have missed something. Yeah, it's a list of messages. So messages, yeah, so human message, essentially the same structure that you pass into the chat prompt template, this list of messages, which can be in this form or in this much looser form, right? It is this list of messages that you pass into an LLM. So that's why I can pass in a list of messages that are just strings. Okay. If I pass in the two to the LLM, it's going to, first one is going to respond to me. So you can now see how you are able to chain your prompt into this because the prompt is going to generate an output. The chat prompt template is going to generate an output that will fit into this. You cannot just chain a regular prompt template, by the way. So that is the um, that's another thing to note, right? So that's another thing to note. Um, yeah, so to now chain the two, the challenge we have is that we cannot just chain a regular prompt to an LLM. We have to use a chat prompt. It has to be a chat prompt template from messages. Okay. And if you have something like this, let me just take okay, let's just go with this. We've done this already. But what I want to show is that when you call invoke on this one, and I don't need to pass in any variables, prompt X, this should be prompt X. You now see that you're having a chat prompt value that has a long list of messages. So this long list of messages is what is going to get pushed into your LLM invoke call. So now, how you put the two together, typically you create a simple prompt. I have created prompt X, which is a chat prompt template, a prompt made from a chat prompt template. So it gives you a chat prompt value. And then I have an LLM. I can then take this prompt X and chain it into the LLM. And that gives me a chain. And then I can invoke the chain as if it is, the chain is a runnable. So when you take runnables and chain them, you still get another runnable. So you can still run invoke on that runnable. And you see that these four messages are going to be sent to the um, LLM, and the LLM is going to give you a response. And the interesting thing is that these four messages here now look like a conversation history. This is basically a conversation history that has been created, where you have the system prompt. Then the first question that was asked, we assume that this was asked in the first iteration of the conversation. Then the AI responded with this. And then the next question, right? So the AI is actually going to take that whole thing, put it in this context window, and then give you this response. And essentially, you have created a chain, right? But this chain has still has the same structure, right? It still has the same structure. Um, it's an AI message. It just the response from chain.invoke is always going to be an AI message. Rather, the response from an LLM is always going to be an AI message, a single AI message. But a single AI message is a structured um, data that has content, which is the actual response from the large language model. And then it has additional information. So apart from the content, which I think the content goes all the way to this point, that's the amount of content that we have. Then it has additional arguments. It has additional metadata, response metadata, the finish reason why the LLM stopped generating. It says stop. A model name, it tells you what model did the job. Safety ratings, model provider is Google Gen AI. And then that's the metadata. Then it has other things. ID, which is the ID for this particular chat session. When you start, most AI providers will actually give you an ID, which you can use to maintain the conversation. Then two calls is the number of two calls that the LLM does. We have not gotten to two calls yet, but we'll get there very soon. We'll talk about that. And then how many of those two calls are invalid? Then there's additional metadata on usage, the number of tokens in the input, which is 29. If you actually count all of these messages, right? Tokens are not always exactly the words, right? There are additional information because LangChain and so on may add additional system messages and so on. So that's why sometimes the tokens that you count may not be the same. But this is 29 tokens. Tokens are roughly words, right? Slightly more than words. In fact, I think it has been said that the number of tokens in a sentence is about 1.3 to 1.5 times the number of words in a sentence. So if you have a sentence and you have 10 words in that sentence, the number of tokens that will be generated is probably going to be about between 13 to 15 words. 13 to 15 tokens. So you can actually count the number of words here. 1, 2, 3, 4, 5, 6, 7, 8, and 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. And then multiply by 1.3, you are really going to get, well, it's much less. This is 29, so I guess it's close enough. Okay, so you get that. The output tokens is the tokens generated by the AI, which is the content primarily, but there could be other things. Then the total tokens will be the sum of the input tokens and the output tokens, which 29 plus 1639 is 1668. And then you can have details of the input tokens and details of the output tokens. Of these output tokens, reasoning, 1143, 1143 of these tokens of the output tokens are actually used for reasoning. So the actual number of output tokens that is sent is much less. I think I have a bit of reasoning in here. If we look very carefully, it's supposed to return reasoning as well. So reasoning is additional information that the LLM will give you about its internal thinking or thought process. I was expecting to see reasoning here, but I can't see anything like reasoning here. So this entire output is likely what is coming from the LLM. And this is invoking a chain. Now, the third thing you always do, right, typically is if you just want to do a very simple thing, like I showed here, is after you have chained the prompt into the model, the output is an AI message. If you want to extract the output, then you can use a string output parser. So a string output parser, you can get it from the output parsers in LangChain core. So let's do that. Import. You can actually take an AI message and chain it into a string output parser, and you get the message. So let's import it from LangChain core. Um, dot output parser. You import the string output parser. So you can then um, take the invocation and still chain it, or you can just make a chain that is made up of the prompt, right? The LLM and the string output parser. You can create an instance and reuse the instance, or you can just do it this way. So now, if you invoke this chain, you get only the output, right? The string output parser removes all the non-output stuff. That is all this metadata, the other things, and just gives you a string. That's why it's called a string output parser. Okay. Yeah. So these are the basic primitives. You have now created a very basic chain. Now, if you want to do something more complicated, right, we will have to do a bit more. So let's look at what we can do in order to basically get our prompt chain, the full prompt chain that we did, last time, which we did manually. Now we want to do it with LangChain, LangChain expression language. So of course we have to create all the prompts. So the way I'll do it is I'll create all of them in a list, right? Like I did before. Prompts equals, I'll just create all of them. Now, these are in files. So as you can already see, you cannot just pull um, chat prompt template from files. You can pull a regular prompt template from files, but you cannot pull chat prompt templates from files. So that provides a bit of a difficulty. Dealing with files and chat prompt templates is not really supported anymore by LangChain, right? So there are two ways you can do this. You can take a regular prompt template, right? Invoke it, but at the point of invoking, it means you cannot inject the parameters, but you can load a regular prompt template and then extract the original template for it, and then use that as a string for your chat prompt template. It's a bit roundabout, right? Um, the other option is you can just open the file and read the file like a standard text file, right? And then use that the string that you have read and use that to initialize your chat prompt template. So, but one thing I've not tried though is putting a regular prompt template into an LLM. So let's see if I can do that. I just want to try that. I don't think it will work because the regular prompt templates, um, like we had prompt, that the regular prompt template is a string prompt value, right? It is not a list of prompt messages. It's not a chat prompt value. But then a string prompt value can be used. So we could also, let's try that. I'm going to actually chain a prompt one, which was already a system prompt. I'll chain it into the LLM, and then I invoke it and pass in the, yeah, so this would also work, right? Yeah, so this works. So you can take a regular prompt. The only thing is that you cannot have that historical is just a single prompt. So for the purpose of what we want to do now, we are going to chain all of the prompts, right? So the first thing we will do, of course, is let's create a list of all the prompts in order to keep track. I don't know which is which anymore. So I'm just going to create prompts list, and then I'm going to start with a system prompt. The system prompt, the value, we will load it with a prompt template um, from file, okay, and so on. Then prompt 3 is also going to be prompt template. And we'll just keep on going like that till um, we get 6 of them. We need to get 6. So we have 4, we have 5, and we have 6. All right. So we have all our prompts, and oh yeah, this should be a dictionary, not a list. Okay. So we have uh, all our prompts in a single prompt thing. So remember the chain that we did the last time, the chain that we did, we had the same 6 prompts here, even though I didn't have the system prompt. But we had the same 1, 2, 3, 4, 5, 6. All right. Now, I had to do this add variables so that we could inject the variables, but LangChain does that for us already. So I don't need to do that. The only thing is we can keep this message as the question, but we can do this at runtime. So now we can create, there are multiple ways you can do this. We can chain all 6, right? We can chain all 6. Alternatively, we can chain, make a chain of each prompt, each round going from the prompt to the LLM and then the string output, right? As separate chains. Then we can chain the chains. So let's do that. So the first thing is we can then, let's make multiple chains. So we can also do the same thing. Um, oh, one other thing is for us to be able to put in a system prompt along with this, um, we have to use the chat prompt message. If not, we will not be able to get the actual system prompt. So if we still need to include the system prompt, the other thing is that we could just concatenate it like we did before. But let's use the chat prompt template. So we can just say chat prompts. This time around, um, let's just use a list. So the first one is from messages. The first message is going to be a system message. So we can just system message, and we will take the message from the prompt. Now, this is going to look as if it is a bit complex, but I'll break it down. What are we actually doing here? In order for us to incorporate system message and human message, um, yeah, well, we could do the output parser, but I'm not going to do the output parser here. So, remember the chat prompt template allows you to do a list of messages. That's the only way you can combine a system message. Well, that's not the only way, but this is kind of like the standard way. You could also concatenate the system message. So what I have done here is, I don't want to invoke this. So I will just pull the original template. I need to try this because LangChain, a lot of stuff has changed. Prompts, okay. System. Um, so I want to show you that you can recover the original template from a yeah, you can recover the original template using this template um property from a prompt template. So that's how I recover the original template, right? And then I use that original template as the template for um the system message. Okay. Same thing here. So not invoke, because invoke is going to inject the um placeholders. We don't want to inject the placeholders yet. We just want to create it. So we create a chat prompt template. This is for the first chain, right? The first chat prompt template. This is for the first um prompt in the chain. This is for the second prompt in the chain, right? This is for the third prompt in the chain. We are still maintaining the same system prompt. This is for the fourth prompt in the chain, and so on. Notice that I am not um, adding any, I'm not adding more than one human message in the prompts. We could always make it like a sequence, but I don't want to do that because we're just chaining. Okay, so um, why I'm doing this is I'm going to take each of these one by one and use them. So for the first chain, so now I'm going to have chains, right? And again, I'm going to create a list of chains because I want to run all the chains. So the first chain is going to be, well, it won't be prompt one. It will be chat prompts 0, and we'll pass it through the LLM and string output parser. So each of these, I'm now creating, from each of these chat prompts templates, I am now creating a chain. So we have this first chain. In fact, let me simplify it this way so that it's easier to understand. Let's have this as multiple variables instead of a list, because a list will be difficult for a few people to grasp. So right. So what we are trying to do here is create multiple prompts, oh sorry, multiple chains. So the first chain is the first from the first prompt, which is, so let's use a name that's a bit more that's easier for us to remember. This was prompt one. Prompt one is the identifying the intent. Okay. So identifying the intent, we can call this intent chain. So the intent chain. Then the next one is from prompt two, which is classifying the request. So we can call it a classify chain. And then the third one is to identify the the nature of the issue, right? What type of issue it is, whether it requires an immediate response or not. So you can call it an urgency chain. And then the fourth one would be to identify whether it is a product inquiry, right? And if it is a product inquiry, what do we do? So let's call this an inquiry chain. Then we'll have a fifth one. The fifth one is to get additional information, right? So you can just call that one an information chain, info chain. Again, we'll still pass it through the LLM and the string output parser. Then the last one is a response chain. So yeah, so we now have the 5 chains that have been created. Um, let's run everything. So I did a roundabout thing here where I used a prompt template to load from file. Then I used the template that it has loaded to initialize a chat prompt template, right? And pass in the system and the human message. Normally, if you don't need to do his system and human message, you can just use the prompt template directly in your chain instead of having to create a chat prompt template, right? So we have these 6 chains, and each chain is a direct API call. The other thing, of course, is the variables. So I'm going to just create the variables. So there are 2 main variables, the customer message and the product info. Right. Now we can chain the chains, but chaining chains is a bit tricky. What we can just do, let's just do, so let me call that one meta chain. So we have the intent chain. I chain it into the classify chain. You really need to chain things if you need the output of one going into the next one as an input. In most cases, that's not really what was happening here, right? Um, but let's see how this works. The main challenge with this is that the output from one may not provide the variables that are needed for the next one. So I expect that this may not work, right? But then again, LangChain knows how to handle things. One of the things I've seen with LangChain is that once you specify all the variables, it is able to figure out each chain, which points where it needs. Um, yeah, so by the way, the meta chain, okay, let's just run the meta chain. I did not include the, yeah, so I pass in this, which probably I should have just passed in the variables I had created. But you see how much nicer this is. I didn't even need to create the variables separately because I only need to invoke the chain ones. And yeah, yeah. So this challenge is let's invoke one chain. So this is likely a challenge that we have. Um, let's let's start with one chain, single chain, intent chain. Yeah. Okay. So this works. So the challenge we are having is that this output here cannot be directly chained into this because the output, whenever you change stuff, the output from one has to be sufficient to form an input to the next. The output from the intent chain, that the input. This intent does not contain the variables and all of the other things that are needed in order to run it. So that is why we are having this challenge. And if you look at the prompts we have, right, you find that the prompts are actually running in parallel. So you don't need to effectively chain them. It is only the last one that needs to be to take inputs. Really, where you are having the product thing, that's where you need to do. So that's a bit more complex, right? So in this case, what you actually need to do is to run them in parallel and to run um, a chain in parallel with LangChain. There is something that we call it's actually called a parallel runnable, right? That allows you to run, or a runnable parallel that allows you to run multiple chains in parallel. So we can do that here from lang chain or dot runnables. Import runnable parallel. There are different kinds of runnables, by the way, and this is something I think we should take some time to study a bit more. Then we can now create an analysis chain. Let's call it analysis chain or yeah, okay. Yeah, let's call it analysis chain. So we will use the runnable parallel. In a runnable parallel, you specify, well, you can specify it as a dictionary, or you can just specify it as a key value. Effectively, I can run all of these chains that I created all in one go, right? I can run all of them. The only difficulty is that if you look at the prompt four needs product info. Well, which um the product info run four requires run three to know whether it's critical or not, and then whether it needs to know whether it is a product inquiry or not. Okay. So, but let's just run all of them in parallel just for simplicity. Um, so we create a chain that is going to run all of them in parallel. That's what the analysis chain does. And then we can invoke the analysis chain with variables. So remember the variables are the variables we have. And so just as you pass in this list, it's going to pass back a response that contains, the response will be keyed. So you now see that for each one, the intent, it gives you the response from the intent chain. For the classify, it also gives you, okay, here is saying, please provide the customer's message. So we have lost that customer's message. For urgency, it is true. I don't know how we managed to lose customer's message in here. Maybe the spelling of, let's see. Here is customer message and variable is customer message. So it shouldn't have lost it, but it seems it has lost it. It's saying that we should provide it. Again, this is saying the same thing. So what I'm seeing here is that the for some of them the variable is not coming true. Um, I am having an issue. That's a customer message. And yeah, this is really only just it's giving us responses, but it looks like the customer message is not getting passed through. Um, well, that's one way, right? We are running it as a single thing. Now, the other way is to run each one separately, okay? And we create context, right? We create a context so that it's always going to be um, available, right? Then there is also a point where for chaining, there is what we call a dynamic routing. Dynamic routing is where you want to decide. That came up here, by the way, in prompt 4. sorry, in prompt 3, in the third step of the chain, we are to determine if the customer's request requires an immediate response or not. So in that situation, what you normally do, let's try that. So that it's going to give a response that it is immediate or not. Um, that's the urgency chain. So let's take this urgency chain and then we invoke it again with the variables. And it's going to give us a response, whether it's urgent or not. So true means it's urgent. Um, Now you can decide which chain to do next. So if the question is, which chain should I, this is a case where the result of this true or false will determine whether you are going to run prompt 4 or you're going to run prompt 5. Prompt 3, if it is urgent, then you can maybe channel it to, you respond, right? You respond to the complaint. But if it is not urgent, then you can do a product request. So let's assume that you needed to decide between which and which. So what you would do is you take the output from this, you take the output from this, and then you would now pass it into um, a whatever name we want to call it, like a conditional chain, right? This is a chain that, so for a conditional chain, you use what we call a runnable branch. A runnable branch is a type of runnable that will decide between one of two options based on, or between multiple options, right? Based on which one is true, based on conditions. And this is how you set it up. So you use a runnable branch, right? If you look, let's look at it carefully. The runnable branch has, you can pass in a list of branches. Each branch is made up of a, a, a let's call it a runnable, right? It's a tuple that has two values. The first value is a function called an anonymous function, which we call a lambda, that will run and then give a value. If that value is true, then it is going to return. Essentially, think of it like an if statement. Okay, if you had a bunch of if statements, let me see if I can explain this runnable branch. If you're writing if statements normally, you would have written something like this: if X is true, right? Then you do something, right? Then you do an else. Okay, you do an else and say else if um Y is true, right? Then you do something else. This is typically how you would do, and then you keep cascading that. The first one that is true, that's what you would do, right? And then you get to the else. The else is the catch-all, okay, which is what you do if none of them is true. That's essentially what a runnable branch is. The difference is that here in a runnable branch, the first condition, so the first condition, right, is now contained in this tuple. So the first condition is contained in this tuple. The first element of the tuple is the condition itself, and the second element in the tuple is what you would do if that condition is true, right? So if I were to take this one I wrote here, which let me comment it out to avoid. So to take this one and write it here, then X is true would be the condition. That's the first part of it. And then do this would be the runnable you want to run. That's the first condition. Then the second, this is the else if, which will be Y is true. That's the condition. Then do something else, right? That is, and we'll just keep doing that until you get to exhaust all the conditions, right? Then when you exhaust all the conditions, you can then specify a runnable lambda. So what's a runnable lambda? A lambda effectively is it's it's a lambda function. I hope we understand what a lambda function is. It's basically a function that an anonymous function, you inline it. You don't need to go and declare the function elsewhere before you come and use it or call it. You just declare it and use it at the same point. That's why it's called an anonymous function. And in Python, a lambda function is you use this syntax where you specify that you use lambda to specify that it's a lambda. And then after that, you have a space. And then all the arguments that will go in. And then you have this colon, which is normally a delimiter in Python. And then you have the actual thing that will be done. In JavaScript, the equivalent of a lambda is what we call well, it's still called an anonymous function or an arrow function, right? In JavaScript. So lambda is basically an arrow function. So typically you would use this to be a lambda as well. In other words, let's say something like this. You could actually also put in a normal function. Okay. So let's try, I want to show you how this works, how a runnable branch works. So first of all, I'm going to create a function. I'm going to create a function to inspect, right? So the essence of this is I want to be able to inspect whatever is going on. So I'll just print, um, right? This will help you to see what's going on. And yeah, I'll just return true all the time. So this is a function I want to use. Let's have a runnable branch and a runnable lambda. So we import those two. We create this function. So instead of putting this lambda, I'm just going to put an inspect. I'm going to put the inspection. And so what this is doing basically is this, if this is true, right, then use the chain that you specify here or the runnable that you specify here. So let's just we have two chains, right, that we want to choose. If the urgency is true, if it is high urgency, then it should respond immediately. If it is not high urgency, then you can either give info or inquiry. So let's just try that. So info, let's do the info chain here. And then again, I'm still going to inspect here again. And then let's do the inquiry chain. If not, we could just return something, maybe just print. Okay, right. So I have created, this is now a kind of more complex thing, but I just want to introduce it a little bit. This is to show you that chains are really a big deal with LangChain. It, chains allow you to do really complex workflows as long as you can understand how to pull them together. So in this case, I'm using a runnable branch. A runnable branch is like an if statement. So basically what this is saying is that if this inspect is true, then I run this chain. But if not, then try the next one. If this inspect is true, then I run this chain. Okay, let me do two versions of inspect. So inspect true and inspect false. So we can kind of understand the logic. So I have inspect true and I will have inspect false. In both cases, we are still going to inspect, but let's start with inspect true at the top. So that means the first one will give us a true value. And so that means because this first one is going to give us a true value, then it means this chain will run first. While this one will give us a false value, this one will not run, even if this were not true. So, okay, so as it is now, I will run this chain. If I run this chain, conditional chain, invoke it, we'll still pass in the variables and we'll see what we get. So you can see that, remember, I was doing several things. So the first thing I did was it will first of all go to inspect true. Inspect true will check the arguments, the args that are passed. There's only one um, positional argument that contains a customer message, I am having an issue, and the product info, some product information, right? There are no keyword arguments. And then it runs the chain. Because it runs the chain, of course, the response to the chain, the yeah, this is the response. I'm ready, please provide customers complaints, and I will craft a polite and helpful response. Now, what I've seen here is that this it did not plug in the variables. So we're going to look at how to do that. Now, let's switch this around a bit. This we now switch and we make the first one to give us false. While this gives the second one gives us true. Now, if we run that one, okay. So the first one is giving us the first one didn't run. That's why it's inspected it, but because it's false, it didn't run, right? But instead is the second inquiry chain that ran, which is giving you this response. I'll be happy to tell you about the gaming headset. Now, let's assume that both are false. Okay. So the expectation is that if both are false, this first one will not run, this second one will not run, right? But what will run will be the last fallback, which will just print default. So if we see default printed, that will tell us that that is what ran. You can see that. So this is how you can then use a runnable branch to switch between which chain runs when you have different different chains where you have to have a branching point to decide which one should run and so on and so forth. So that's a runnable lambda. So now for you to combine all of this, right, into something that does what we expect, we would have to um, we take the customer message, we'll run it through a runnable parallel. The runnable parallel will contain the first three prompts, right? And then we'll take the output from that, okay? And then we'll take that output and we will put it into the runnable branch that will then decide based on the response, whether to do a product lookup with the info chain if the response is true, if it's urgent, or to handle, sorry, if it is not urgent, then it will do a product lookup. But if it's urgent, it will do an immediate response. Okay. And then we'll pass that into the final response that will, the final, you know, um, runnable that will generate the response, or the final chain that will generate the response. So let me just pull everything together. Okay, so let's um let's start with the first one. Um, we'll combine the first three. We had already combined. We'll combine the first three with a runnable parallel analysis chain. Let me just simplify everything. Okay, so intent is going to come first, right? Um, classify urgency. So we'll take these three first. Uh, then you can invoke that. So responses. So these are the responses from the analysis chain. Let me make a new variable where we'll have the customer message with making a purchase in on your site. It is urgent. So I'm putting it is urgent. So now we don't need the product info in this case. We don't need the product info in this case. So again, let me just double check. So we are doing prompt one and prompt two. Prompt one is requires customer message. Prompt two also requires customer message, and prompt three requires customer message as well. Um, so we'll just run this first three. We don't need the customer. Um, yeah, we don't need the product info yet. Okay, I think I have exhausted my um yeah, I've exhausted my I've done a lot. So yeah, I will need to basically start afresh with a new model. So let's do that. But I'm not going to run all of the stuff I ran before. Let's use a new LLM from um let's pip install chat lang chain um OpenAI. Yeah. And then customer message. I'm just checking to ensure that that all the customer message variables are the same. Okay. Yeah, so I'm going to use from LangChain OpenAI, import chat OpenAI, and I'm going to create a new LLM. Is So I'm going to use um well, I don't know if this is, let's just try this first. GPT. Um, oh yeah, okay, let's use Open Router. So I could also have Open Router. I'm not sure of that spelling. Let's install that. There are a lot of integrations that LangChain has for almost all of the providers currently, for Anthropic, OpenAI, Open Router, Grok, um, a whole bunch of them. I can try out all of them. I think I may have spelled this. Open. Okay. All right. So I'm going to use this then. Then for the model, um, yeah, I need to get the API key as well. Okay. So, all right. The model as well, we will use Nemotron. I use that a lot. Okay, so I have yeah, I'm going to put in Nemotron here. Okay. Um, NVIDIA HEB A3B 3. Okay, so we'll go with this. Um, okay, API key, so I need to reload the .m file. Um, okay, this is the .m file. Okay, so we'll run this. Well, it looks like the .m file didn't pick up, so I'm going to restart this. Yeah, I have I think I'll just go ahead with this. Um, um, okay, so let's start again. I have to start running this. But I believe the imports are in place already. It's just the .m file that doesn't seem to be loading. But let's try again. And we now have a new LLM. Okay. Um, okay. Let's rerun it. Let's run it again. Restart session so that it can reload the .m variables. Um, so we will have all of the I'll have to run everything, but let's start from here. Google Gen AI um, load.m okay, install LangChain, open router, import LangChain open router, and then create a new LLM. I think we'll complete this when we come in next week. Yeah. So I have LLM now. So we'll build the chains now. I'll just come straight here. So we have all the prompts. We'll load all the prompts here. Then we have all the chat prompts. We just have the chat prompts just in case. I need to import the chat prompt template. Let me go do that. I somehow missed that. So import the chat prompt template class. Then we now run all the chat prompts. Okay, I need to import system message, human message. Let's see where we have that. Uh, human message. Okay, there it is. So I need to import this one as well. And then now chat prompts. Okay. Then I have all the chains now. Okay, I need to import string output parser. That is here. Okay. So we now create the chains. Okay, so all the chains are in place. We now create variables. We can now continue from here. So I did this first one, which is the analysis chain. Okay, I need to import the runnable parallel. So import the runnable parallel, runnable lambda. Let me import the runnable parallel here as well. So parallel. Okay. Then we run this. So we have the analysis chain, and then we can invoke it. So hopefully I don't run out of all right. So we are good to go. So we have responses now. So these responses is, even though I'm still surprised that this is telling me, it has given me urgency is false, even though my, okay, I did not specify it's urgent. So let me specify that now. But I'm still surprised that it's saying we should give more information. I would have expected, please provide a customer's message. So I think the runnable parallel, for some reason, I am invoking it, I am passing in the variables. Maybe I have misspelled it. This is customer message. The prompt is also containing customer message. So, but it looks like it looks like for some reason the runnable parallel is not getting the customer message variable injected, because that's why the LLM is saying that it's not we should still provide the message. Even the classify the same thing. Urgency, immediate response is false. So we'll do more of this when we come next week, right? The LangChain basic chaining works, right? These more advanced chaining methods is a bit you need to do a bit of debugging around it. So when we meet next week, I'm actually going to share again what I have done from this and how I was able to fix it. If you take this and you do a simple chain, like you take each of them, well, maybe a simple way to debug is to take a simple chain and then run it and see what happens. It's a good way of debugging it, debug individual chains. If this fails, um, if this fails, okay. So I think the problem is the variables that we are using, or the fact that we are using a chain of chat prompt messages. Okay, I know what I have missed. So for the chat prompt template, we needed to add the um we are not yeah, we did not include the variable zone pass through. So this method is not the right approach. It's actually taking the template, but for some reason the chat prompt template is actually not taking the variables in. So the best way for us is to let's use the original chains. We will lose the system messages, but at least we'll be able to get the original. So let's go with the original prompts and we can try that. So the intent chain now, we will use the prompts, we'll use prompts, prompts one for that. And basically this is what worked before. I think the approach of trying to inject into chat message prompts, we have to use a different approach. Prompt two. So this is prompt one, prompt two, prompt three, prompt four, prompt five, prompt six. So this is where it all broke. Now we don't have now it's going to work because at this point we'll need to do a new rerun this again, rerun this again, rerun this. And this time we should get what we want. Responses will give us what we want as well. Okay, so it's been able to respond based on the customer who say I'm having an issue making a purchase. It's urgent. Um, there's a whole lot of verbosity here, so maybe the prompt wasn't strong enough. That's intent. Classification has given us that it's a technical support issue. Urgency is true. So we have gotten the responses from these three. So the next thing would be based on urgency, we can then take this response and use it as the basis for the runnable branch. So the runnable branch is, we are going to put a lambda in the runnable branch that we will use to determine whether, so let's do a runnable branch, right? And the first condition is going to just be a lambda that will help us to check based on the inputs, right? Let's do this again. But this time around, the runnable branch, we are going to chain it from inspect false. We are going to chain the runnable branch from, yeah, let me be sure I have inspect true and inspect false. Now I'm going to chain the runnable branch from the response that we get, right? We are going to take the response that we get from the urgency chain and use it. So we have a runnable branch, which we will chain with the, let's just do this separately. So you have the conditional, then we're going to chain the runnable branch with the response from from the analysis chain, but we're going to just take only the urgency response. So if we take the Yeah. Um, so I'm just going to do this. The essence of it is we take the analysis chain, we chain into the conditional, and then you can now see that the output from this um the output from the responses, right, from the analysis chain is what we are now using or we are now receiving as the input. So we receive the intent, right, as complaint, we receive the classify, and we receive the urgency. So this now informs us on how we will handle this this lambda. So the simple way to do this is lambda, um, let's just call it input. So this input is going to be what came in here from the previous chain. And then we will now just say urgency, right? Input urgency. If the urgency is true, right? If the urgency is true, then you use the chain that will respond immediately to the customer's problem. And the chain that will respond immediately to the customer's problem is the response chain, right? Um, you do inquiry, you do the inquiry first, and then you do response, right? So um, inquiry, and then you do response. And yeah, response chain. And you can see that we're actually chaining two chains. But if not, we can just do if it is not urgent, then you can just do the product, right? The products, what was it again? Product, the info chain, right? Info chain, which is the product information. So we now create this. So in a way, we have taken this whole thing and we have broken it up. And um, with this, if we now run this, we are going to um, yeah, we input to prompt template. Oh yeah. So there's a thing that's happened here. Um so we need to augment the I think I'll have to break off here. I'll do the rest next week because we're out of time. And now why we're having this error here is we have um in this runnable branch, we have uh, the previous chain, this analysis chain has generated an output that has intent in it, right? It has intent, it has classify, and it has urgency, but it doesn't have the original customer message. So this output is now passed into conditional, the conditional still needs this customer message as part of its input. So for us to be able to chain these two, we first of all have to add the um, the original custom message variables as well to the output that comes from this chain so that it can move on to the next chain. And that's typically a problem that we face. If you are chaining a lot of stuff with long chain, you tend to have that situation where the the variables are, you need to bring in new, you need to kind of re-inject the variable back into the output that comes from a previous one. We are going to look at that next week when we come in. I'm going to complete this and I'll try to explain what I have done in a way that is easier to understand. Yeah, I was trying to go into some more advanced aspects of chaining with LangChain, and I hope we have learned a bit. Just as a recap or a summary, you can do simple chains by taking a prompt, right? And then chaining it with an LLM. This is what we did here, right? You take a prompt, you chain it with an LLM, and then you can chain it with a string output parser, right? So it takes the string output from the LLM, just the output without all the metadata, right? That's a simple chain, right? Now you can take the simple chain and you can combine them in different ways. The normal chaining is a sequential way, but when you are chaining, always remember that the output from one chain becomes the input to the next chain. So if the input to the next chain requires some additional, especially the prompt requires some additional um, variables, then you have to inject it. We'll talk about that next week. Um, then you can run multiple chains in parallel by using this runnable parallel. So the runnable parallel allows you to run chains that don't depend on each other, but you need to run all of them at once. So you can do that with this. Okay. Then you can use the runnable branch to branch based on conditions. And these conditions, you can express them as functions. Those functions can be normal functions like this, which I just did, or those functions can be lambda functions like this, which are anonymous functions. So whichever one you use, if the response or the return value from this function is a true value, then the chain that is next to that function will be run. And that is all. Once that chain is run, no other chain will be run after that. It will just run this chain and stop. But if it is false, it will fall to the next tuple or pair in that sequence, and it will check again. If the function returns a true value, then it will run. If it keeps going and it doesn't see anything, then it will run the last one that is not a tuple, right? But if it doesn't see one that doesn't have a condition attached to it, then it will just end up not running anything. So just like a standard if statement. So that's a runnable branch. Then of course we have a runnable lambda, which is a third type of runnable. There are lots of runnables in LangChain, and you basically compose chains by bringing all of these together. A runnable lambda is basically a runnable that you wrap around a lambda function. So whatever you have in this lambda is going to run as a chain. So those are the main primitives that you can use for building chains in LangChain. Now, the when we come in next week, we are going to talk about the variables. We've already seen that LangChain handles variables for us, right? You can just directly pass in a variable. But the interesting thing is that when you pass a variable in, something else comes out on the other side of the chain, which is based on the processing that the LLM does and everything. Now, if you take that chain and you chain it into another chain, right? And that um, new chain has additional variables that are needed in the prompt. You need to inject those variables in. So when we come in next week, we are going to look at how to do that. And that's the last piece of the puzzle. Once we have been able to do that, then we will assemble all of this to form a complete chain that can do almost anything. So with this, you can always almost build anything. And yeah, at least we'll be able to redo that same chaining that we did, but this time we use LCEL, Lang Chains Expression Language. So that is all. I hope we have learned a bit about LCEL. There's a lot involved, and the rest of it, we'll handle it when we come in. That's all from me. Are there any questions? Okay. If there are no questions, then we will close.